this is also funded by European Union. So this is not Katamas anymore, so I put it this way. So it's Precikem now that I'm representing. We have a 9-hectare big field for testing subsurface drainage with subsurface irrigation, and we put in some chemicals into the stuff that we pump in to the soil. So that's the new thing about this site. And we have like
megaphone.
do we have that? So we have a test site with 9 subfields. We are trialing pumping in chemicals into the system through the subsurface irrigation system. And this place is number 1, where we will present some things about this field. Then we have site number 2 is at the 10th, and there we will have about laboratory experiments. Site number 3 is a little bit further away. There Mark Dodson will talk about microbiology. And site 4 is over there, where we show how we inject the chemicals into the ground. So 4 stations, and you can walk down to Tubu River. So we are now here, and we should turn this map over. Tubu River is about 500 meters in that direction. And that's also the place from where we take the irrigation water. So we are actually pumping water almost 1 kilometer in the furthest place. And we are now half a meter below the sea level, so the elevation difference is not very big, but the distance is quite far. So we are now standing below sea level. This map is 100 years old, and you can see here it was a bay. Here we have Tubu River coming into this bay. We have had a land uplift, but also very importantly we have a lot of sedimentation in these bays, and these are typical places where sulfides are formed in estuaries like this. So we are now standing inside this red box here, and this has been drained this area by a pumping station and subsurface irrigation. So Rainer will talk more about this system, how it works. So I leave it to you, Rainer.
Okay, okay. Yes, I will explain the installations. We have drainage systems in each plot, and they are just
Similar, identical.
Yeah, similar, identical in each plot of the test field. And we have 9 subfields in this area, and the whole area is 9 hectares. So we have a collector pipe, which is 100 millimeters pipe, and we have drain pipes, 80 millimeters, 3 per plot. And we have a control well, where we can control the outflow and inflow. And we have flush pipes in the end of the drain pipes. So in station 3 we will go with a camera into the drain pipe, so you can see in the TV what is in the pipe, if we have limestone or something like that in the pipe. And we have also surrounded the test fields with a plastic sheet like Risöfladan in the same way, but in plot 2 we have no plastic sheet to the main drain, so it can leak out. We will find out how much will it leak out jämfört med, vad är det på engelska?
In comparison with the one which is isolated.
Yes, yes.
So it's a reference for that.
And we have different suspensions. We have calcium hydroxide, and we had calcium carbonate into the plots. And we have this one. We have made nothing to, but in some ones we had only pumped water from Tubu River, and in the other ones we have suspensions. So we have built a water pipe and a pump station nearby the Tubu River. This is pumping water to each subfield like this, to each control well. so we can have irrigation water to it. And then we have groundwater pipes, 4 per subfield, where we can control the flow and the water quality and the level. If we are looking at the system which I was showing in Risöfladan, we have the drainage, we have the control well, we are pumping water, but we are making a suspension which goes to the drain out to the field in the drainage system. So we get a higher level with suspension over the sulfide. This is the system.